right, guys, let's take a look at Unit 3, Lesson B. And what I want to do is just remind you, this is a review of slope. So take a look at positive slope. It goes up to the right. Negative slope goes down to the right. Zero slope is a horizontal line. It's perfectly flat. And then undefined is a vertical line. And so let's talk about slope dude. Remember, slope dude, let's say that he is a little stick figure where my mouse is. So if he's skiing, he is going puff, puff, positive, up the mountain, right? And then it's nice, negative as he goes down the mountain. A zero slope would be a lot of hard work as well, because if you've ever skied, you need an incline. You need to go down the mountain for it to be any fun. So this is zero fun because he's having to use his ski poles as he goes across. He's using his ski poles to move himself forward because it's zero fun. All right, and then undefined. This is the math curse word. If you come up to a cliff, this is undefined as he goes tumbling down the mountain, creating this avalanche, right? This would be not possible to ski down, so it's undefined. All right, so you can also, let's just look at this here still again. You can also talk about increasing, decreasing with positive and negative slope. All right, this would not be increasing or decreasing, and the word for that is constant. It remains the same. And so let's go ahead and go down here. And if you notice, we have a positive slope. It's up to the right. So this is an increasing function. If we're looking at a table, as x increases, right, we're going from negatives through zero to the positives. As x increases, y also increases. If we look at this negative slope, here's a negative slope. We can tell it's decreasing from. So we're looking at the table of values to determine if it's decreasing. And I need you guys to change something here. Hopefully you notice this. As x increases, we're going from negatives to positives. What is y doing? It's going from 5 to 2 to 0 to the negatives. It's decreasing, right? And that's what makes sense. So y is decreasing as x increases. Alrighty, so let's scroll down and just briefly talk about this example. If we wanted to know the slope of the line, we would go rise over run. And I'll do an example like this, but we want to check, look over at your scale. We are going up by fives, 5, 10, 15, 20, and they don't put it all on the labels. They're just labeling every 10. But even if they labeled it all, you just need to look at the grid line. See, we have a grid line halfway between 0 and 10. So I can tell it's going by fives. So going by fives on the left, which is the y-axis, and then over here, let's take a look at the grid lines. Ooh, what is halfway between 0 and 0.5? Think 0 and 50 cents. It would be 0.25. So we're actually going by 0.25s. So as you're doing rise and run, you need to be aware of what your x and your y axis is doing. All right. Oh, I need to delete that. All right. So all of this I know you can do. And so let's take a look at if it's increasing or decreasing. And I'd like to start working number 7. Choose whether the function is increasing or decreasing in this scenario. Gary is losing weight each week to qualify for a different wrestling class. So if he's losing weight, as the weeks go on, as the weeks increase, Gary is losing weight, which it's decreasing. So he is decreasing. That makes the function decreasing. All right, let's look at this one. As X, let's see, 65, 51, 37. It looks like X is going down. So as X is going down, Y, ooh, we got some fractions here. Well, I don't really want to compare these two. You can because you have a calculator. But let's look from a negative 1 over 2 to a negative 2. What is happening? So Y is going from a negative 1/2 to a negative 2. And so negative 1/2 to negative 2, that's decreasing, getting further in debt. So let's look at X. What's X doing? X is going from 65 all the way to 10. So it's going down. So it's not what you would expect. As X decreases, Y decreases. So which one is that the same as? Let's get a visual of this really quick. There we go. So if I were to plot this really quickly for you, you'd be able to see. So as X decreases, Y decreases. All right. So let's say we are going from 10 to 65. So 10, 20, 30, 40, 50, 60, 70. That'll work. So I'm going to plot the point 65, negative 1/2. So be right about in here. Then I'm going to plot, I'm just going to pick 2 points to plot. The first one, 65, negative 1/2. So that's here. And then I'm going to do 10, negative 2. 10, negative 2. Okay. Draw a line, extend it. What type of function is that? It's increasing, right? Here's your slope, dude. He's going up to the right. As X increases, Y increases as well. Well, what happens if it decreases? As X goes this way, what is happening? It also decreases. So when it's the same like this, it's positive or increasing. Let me write this so you can see. Okay, so as X increases, Y increases. As X decreases, Y decreases. You're going back down. So it's a positive slope. And we say that overall, it's increasing. That one is really tricky. That's why I wanted to start with it. They're seeing if you can kind of visualize what's happening here. So if you want to memorize this, that they are the same, right? So when they are the same, then it's an increasing function. Okay. The volume of a pool, the volume of water in a pool is changing as the pool is being filled. Well, if it's filling up, as the time increases, the volume increases, right? You're filling it up. That would be an increasing function or a positive slope. All right, let's look down here and go to the graph. This equation is pretty crazy, so I'm going to just do what we've been doing and go to the graph. It wants us to find the slope, and so we need to plot the points G and H. Now, let's make sure they didn't give it to us. Nope, just says choose the slope for G and H. All right, so G's location is 24, going all the way up to 210. So G is the point 24, 210. H is the point 36, go up, and it's right in between. Oh boy, we've got to figure out what that is. How can we figure out what that is? There's a few ways. Well, I find it easiest to go down here. It's hopping from 0 to 70, but there's this one in between. So what's halfway between 0 and 70? If you need the calculator, you can do that. You would just do 70 divided by 2. We are going by 35s. 35, 70. Let's add 35. 105, 140. We go all the way up here to H. So I just need to add 280 and 35 to see that location. So I'm right here at 315. Let me write that in. Let's do it with a text box right here. 315, so I don't forget. Okay. All right, so point H is over 36 up 315. All right, let's do what we have been doing. We want to distinguish between the Y's and the X's. That one's running out. We'll use gray. So I'm circling my Y values. Remember, it's alphabetical order and an ordered pair, X, Y, X, Y. And the slope formula is the change in Y's over the change in X's. So I need to subtract these. So I'm going to do 315 minus 210. Since I started with that one and subtracted, I need to be consistent and start with the 36 and subtract 24. Make sure you start in the same place. So I do bottom up, bottom up. Okay, let's go to our calculator. And let's quit out of there so we can just use the calculator. 315 minus 210. All right, that numerator is 105. And then 36 minus 24 is 12. Last step is to divide. So I'm going to do 105 divided by 12. Looks like the slope is 8.75. All right, 8.75 is our slope. Okay, unit rate means for one. So let's look. For 1 week, what would his balance be? And so unit rate, we're looking at number of weeks. So that's per week. So I'm going to use my answer eliminator and let's eliminate the per day because the graph is in weeks. All right, that helps a lot. Well, the unit rate is actually our slope. So we get to select our slope as the unit rate. All right, so let me pause here and go back. Here we go. So it says Ariel has an app that uses the linear equation y equals, woo, look at all that. Okay, so Fred's was graphed, Ariel's is here. I want to show you a really cool trick. This is a crazy function here, but we have calculators. Notice it's a y equals equation. You have a y equals button right here. Go to y equals. I'm going to go ahead and do it with you. And we're going to type this whole thing in exactly as you see it. Negative 82.9 plus 22.4 x plus 3 times the parentheses 27.6 minus 4.3 x, close the parentheses. You just want to double check that you copied the right side of the equation exactly. All right, if you want a visual, there it is. You can click graph, but let's see what they wanted. Okay, simplify the linear equation. If you notice, do you see how it's 18.1x, 18.1x, 9.5x, 2.59x? These are all the slopes. So let me show you how to calculate slope from an equation. Here's your equation. you can go to Calc right here, Calc. Hit second trace to calculate. And we'll be working with this all year. I'm going to show you how to calculate all these things in your calculator. But what is slope? You have to know that it's the change in y's over the change in x's, which is right here. Change in y over change in x. So 6 is the option that you need to select. And then you do have to hit enter. Hit enter, and guess what? The change in y over the change in x is 9.5. That means your equation, because it goes through 0, 0, your equation is y equals 9.5x. How cool is that? So the slope, you guys can do that. And you can do that as well. And then I'm going to let you guys pick number 15 as well. I really think that lesson 8 is going to be easier than some of the previous lessons because we are reviewing. Okay, if you need any help, please hop on my classroom.